Well, time to get started on today's sheet. You know, sometimes I say the same things over and over again. The reason I do that is because I see the same counterproductive things that you're doing, and I want to make sure that they're corrected. People talk about what good school is and what they use this stuff for. The whole idea of a kid being able to go to lunch and have the fun that you had at lunch, and then run around outside, and then come in and shift gears to know that it's work time. And particularly, if the work's not coming easy, to be able to find a way to focus and get the most out of yourself. When that happens, that's really what it takes to be successful in this world, or one of the things it takes. And as such, being able to concentrate, focus, knowing when to have fun, knowing when to work, and so on and so forth, that's a great benefit to you, and it will take you very, very far in life. And sometimes when you come in the room, today's actually been a good day, but sometimes I see it takes a little while to settle down. And then it's time lost that you never get back again, opportunities to learn that you'll never get a second chance to learn again. So we want to make sure we're on top of this stuff from the beginning. Okay, number one says 4 to the negative 2 plus 9 to the 0. And this question, in addition to being a fairly popular kind of question on a test, is also a good question because it helps us work with negative exponents, which has a piece that'll become positive later, and 0 exponents, okay? So it says to evaluate 4 to the negative 2 plus 9 to the 0. Negative exponent. So that's 1 over 4 to the positive 2. What is 1 over 4? What is 4 squared? 16. If somebody's going to get that wrong for 4 squared, what do you think they're going to say 4 squared is if they're going to get it wrong? 8. That's right. We call that the right wrong answer. Mr. Braze, who was the dominant influence on me to become a math teacher, he used to say that all the time in class. What's the right wrong answer? What's the mistake? And he was actually teaching kids what the possible mistakes were before they ever took the test. So the right wrong answer would be 8. 1 over 16 is correct. What is 9 to the 0? 1. Anything to the 0 is 1. So 1/16 plus 1 is 1 in the 16th. Okay? Now, somebody want to give me an estimate how many times you've seen a question like that? No, sit down. Sit. No, sit. Listen, guys, when we have a little piece of paper we want to throw out, I'm glad you want to throw it out. But wait, because then you interrupt. When you stand up, everybody pays attention to you, and then their attention's not here. All right, so anyway,
See, now what was I just saying?
oh, how many times have you seen a question like this?
About
20? Yeah, 15, 20, 25, whatever it is. Have you seen it enough times to know how to do it? Yeah, so if you're not getting it right, got to straighten that out, okay? I know this much. I know if I walked around to every one of your desks and I said, here's a $100 gift card to the mall. Here's a $100 gift card to the mall. All you got to do is know how to get that question right tomorrow. Every person in this room would get that question right. You know what I did last night that I never do?
What?
I played Mega Millions.
What's that?
It's like Lotto. It's $117 million.
Did you win?
I don't know. I don't think they actually have the drawing until Wednesday.
Oh, bro, never.
So, and a lot of times when I play these things, I really don't think I win anything.
What
So,
number did you win?
what's that?
What number?
All right, I got a bunch of numbers. You got to. I played $5 worth. I think it's $1 a chance. So, I'm gonna try, see if I happen to win it. Who knows?
If you win it,
If you win.
can you take us to Taco Bell?
No, but if I win, I will do this. I will teach to the end of this year, and then I will retire.
No.
Oh, I will.
They don't win.
I will. No. I will also say to each of you that if you can get an 85 or higher in this class for the year, I'll give you some big bucks.
Well, how big is a
Sorry,
big
sorry,
flaw?
Like,
There's a big flaw here.
I'll
How
say
big is
something
big
like, I'll
bucks?
put like $2,000 on every kid's desk and say that
Okay.
$2,000 is yours if you can pass.
You pass, it's gonna have to be $500.
Now, you know what? I'm glad you're lighting up about this because here's the ironic thing. You ready? Here's the ironic thing. Do you know that the average math-related career, and all right, let's not do math. let's do if you graduate high school versus if you don't. If you graduate high school, you tend to make in the neighborhood of about $15,000 more a year than if you don't graduate high school. If you graduate college, a 4-year degree, you make another $30,000 a year on top of that. So that's $45,000 extra dollars to go through college or a good vocational school, like a mechanic or something like that. And then if you go out and you get a master's degree, you tend to make another $20,000 to $30,000 on top of that. So let's add it all up and let's just say $50,000 to go get the degree. And you're going to work for about 21 to 61. You're going to work for about 40 years. Anybody know what 40 times 50,000 is?
Million.
Can I use my phone
2
for
million.
this?
$2 million. So my question to you is it worth doing your schoolwork for $2 million?
Yes.
Yes, it is. But because I can't take it out of my wallet and put $2,000 on your desk right now, you're like, see, this is how unaware kids can be. Here's $2,000. You're like, yo, baby, I'm going to do my work now. But I don't have it to give you. I hope I win. If I win, I will. I'm a man of my word. But if instead, you don't even need the $2,000 from me. If you just do your work, you get $2 million. Don't you want the 2 mil?
Well, I mean, it's,
But some kids will sit there and go, nah, I don't want to do any
But
work.
that's student
it's gonna
debt,
be
though.
gone. Like,
$2 million will be gone?
yeah, but why are
The student
really
loans.
wasting it? It's,
The debt.
Well, you know what? I don't think it's a matter of wasting.
Bye.
Like, for instance, I do a lot of tutoring, and I do tutoring for a few different reasons and home teaching. But at the end of the year, there's always some money left over, and then I get toys. Like, I have really nice camera stuff, very expensive camera stuff. And I could not afford it if it wasn't for the extra work. But that, I use money at the end of the year for that kind of stuff, for all of my extra hard work. Okay. Which choice best describes the number of solutions for this? So if we did this, right? If I distribute the 5, I would get 5x minus 15 equals, and now if I do same side, what's 2x's plus 3x's? 5x minus 15. So then I would minus 5x's from both sides, and I get, minus 15 equals minus 15. Now, is that never true, or is that always true? Is it never true or always true? That it's always true. So if it's always true, it's always an answer. Everything is an answer. There are infinite solutions. Okay?
just one.
What was that?
I don't know.
The answer is not negative 15 equals negative 15. The fact that negative 15 does equals negative 15 means that if you ever plug any number in for x, it will always check. So all things are answers. All right, number 3. Tommy. He's actually my nephew. And being my nephew, Tommy is a little like my son Jimmy. They know how to care for their money. Tommy is not sure how many dollars is in his bank account. He acts like the Grand Deacon of Dinero to tell him. That should say asks. I guess I typed wrong. He asked the Grand Deacon of Dinero to tell him, and the Grand Deacon says, I will give you a hint. If you double the number of dollars and then add 75 to it, the result is the same as if you multiply the number of dollars by 5 and then subtract 12 from it. How much money does Tommy have in his bank account? All right, so here we go. Ready? Does anybody care about the Grand Deacon of Dinero?
Yes.
Who's that?
It's like the Wizard of Oz. So I'm going to cross all this stuff out because I don't care.
Me too.
I like to cross out stuff that doesn't mean anything. So I just basically cut the problem pretty much in half. Then it says, if you double the number of dollars and add 75. So what kind of expression could you write? Let's let D be dollars. What's that? I thought you said something. How could I write an expression to double the number of dollars, D, plus 75? Go ahead. All right, I'm just going to use a D for dollars. But if you use an X, that's just as good as my D. I just like the D because it reminds me we're talking about dollars, okay? But a lot of people would use X. In fact, probably more people would use X than D. And then add 75 to it. Good. So again, we take a piece of information, we write a conclusion, and we move on. The result is the same as. What does that mean? Talk to me, math terms. The result is the same as. What does that mean? Come on, somebody other than Angela. Go ahead.
It equals the same.
Equals, good. So I'm going to cross that out. You know, in the last class, the period after this, you could ask them. I rearranged all their seats. And the reason that I rearranged all their seats is because they didn't produce on the test. When I see people talking to each other, there are two possibilities. The two people could be talking about math and improving with math. If that's the case, I don't want to separate them. I want them to stay together. The other possibility is that they're talking about something non-math related. And that usually means that one person is not in the mood to do math, and the other person who might be is getting distracted. So I don't want them to be distracted. So then I separate them. So if you're talking about non-math stuff, I do notice, and once I have a bad grade to separate you, I will do it. So be aware. Now, if you multiply the number of dollars by 5 and then subtract 12. So how do I write an expression for that? Multiply the number of dollars by 5, subtract 12.
5 times D minus 12.
That's right. 5D minus 12. So I'm going to cross that off. Now what's really cool, if you look at this, everything that gets crossed off has been used. So that means I don't need to write anything else. Then it says, how much money does Tommy have in his bank account? And if you remember, one of the things I said is so great about crossing stuff out as you go along is at the end, you're going to be left with the directions, the thing that tells you what to do. Now, isn't it true that so often when you read word problems, you don't know where to start, and you sometimes don't even know what they're looking for? So by crossing things off, you're doing little pieces at a time. That tells you where to start. It tells you the path to follow. And at the end, it tells you ultimately what it is you're looking to find. All right, so 2D plus 75 is 5D minus 12. What should I do first to both sides?
Take the greater unless take the 2D and subtract.
Yeah, you always want to start with the smaller one. So I'm going to subtract 2D from both sides. Die. 75 equals 5D minus 12. 3D, I'm sorry. Almost did that wrong. And now, what's my next step? Jason, what do we got to do next here, bud? No, we don't want to divide yet. One step before the division. Jerry, what do we got?
Subtract 3D to 75.
No, I don't want to. First off, I would always want to put D's with D's. Right? I want numbers with numbers. I want D's with D's. I want letters on one side, numbers on the other. Jay wants a second shot here. Well, let's not call it put, okay? Let's say I'm going to do the opposite. Since this says minus 12, what's the opposite of minus 12? Opposite of minus 12? Add 12. And I do that to both sides. Now, did you notice what Jason said? Jason said, put the 12 over there on that side. It's more than just putting it, it's always putting it on both sides. Everything you do is always to both sides. It's just that this side goes die, so you kind of ignore it because it disappears, okay? On this side, I get 87 equals 3D. Now the D is being multiplied by 3. What's the opposite of multiplying by 3?
Dividing.
Divide by 3. So 87 divided by 3 is 29.
I got you.
Okay? Now, I looked at Thomas's paper. Can I see that?
I did a lot of work.
Can I tell you something? I was really proud of you. I really did. Because some kids, they look at a problem and they just say, forget it. I don't want to give it the effort because they're really lazy. And they don't think effort's worth anything. This is Thomas's work. Now, Thomas, this is a really good thing to do. This is a better thing. And this is why we learn algebra. You did a great job on this. Don't let anyone tell you that you didn't. But can you see that the way I showed you is a little simpler? All right? And if you guys are looking for a reason to learn the algebraic way, if we tried to do everything Thomas's way, it would work. But how long is it going to take? You know what I mean? So with the algebra, we learn to take something complicated and to think on a higher level. And by thinking on a higher level and using some logic and some reasoning and some skills, we're able to get to the solution quicker, better, and more soundly. And that's the kind of intelligence that one day people will pay you good money for. Okay? Rach, you with me here? Yeah? All right. Any other questions about this? All right, so let's talk about today's lesson. And all we're going to be doing, I forget if this is for a week or 2 or 3. I frankly forget how long this is for.
Wait, Mr. Lundquist,
Yes.
you didn't answer the question. It said, how much money does he have in the bank account?
Oh, D was 29, and then did it say he has what? What was that first sentence about how much money he has in the bank?
How much money do you have in the bank? It's,
But the first sentence said, after the Grand Deacon Dinero stuff, it said something like it's 12 more than 5 times.
I
Five
transferred
times
to
12
it.
minus 3.
Let me read your question real quick. It might be 29 is the answer, okay?
Who puts $29?
I'll give you a hint. If you double the number of dollars in it, yeah, it is 29, okay?
How much money does he have in his bank account?
$29.
No, because
Damn.
2x, you have to multiply.
No, it says if you play with that number, you get this. But the actual amount that you start with is D. Now, sometimes they'll say, for argument's sake, you might like, let's say it was for an angle. That, or they'll say a bank account, they'll say the amount of money in the account is 2 times X plus 12, but they didn't say that this time. They said the amount is D or X. So it works out to 29. All right, today's lesson. First, you have to survey the scene or whatever's going on. You know what every coach in this district, every coach in every school district has?
What coach?
They have 3 courses. They have one called Care and Prevention of Athletic Injuries, which means that you recognize when a kid is hurt and you know what you can do to stabilize. That's obviously important. The second thing is they're supposed to have a course in the sports specific. I did coach soccer for a while here. I am an awful soccer coach. I'm a very good coach. I'm just not a good soccer coach because I don't know anything about soccer. And yeah, well, no, actually, I knew enough to do this. We never had a losing season. And all I knew was if we controlled the middle of the field, the other team would have a very hard time scoring. And I would put my best players at center mid, center, we call them a stopper, sweeper, and center forward. And I'd put my fastest kid on either right or left, depending on if they were right or lefty, forward wing. And I would kick the ball into the corner as far as they could. They would win the race, and everybody run up the middle, and we'd kick it to the middle, and we'd just try to overwhelm them. And then on defense, we wouldn't let them anywhere near the middle of the field. And I coached wrestling, so I had all my wrestlers playing just to stay in shape. And the wrestlers would just drive the other guys crazy. They hated me. And I also coached girls, and I never had a losing season with the girls either. But every year, I used to go to the AD, and I used to say, listen, the minute you guys get someone who knows anything about soccer, just fire me. And let the soccer coach come in who knows something about soccer, because I knew nothing about soccer. But I did know hockey, and I used some hockey fundamentals, just like I asked you guys to use math fundamentals. And whatchamacallit, we had a certain system, a certain way that we went about doing things on a day-by-day basis. Now, let me just look. There was something here that reminded me of that. Come on.
You have to click the marker thingy.
Nope, here we go. It was just taking a little while to load up. So the other thing every coach has, every coach also has the sports specific. I never had it for soccer, so that's why I used to tell them to fire me. And the third thing we have is first aid. We have to have first aid. If you don't have first aid, you're not allowed to coach. And when you get first aid, the first thing they teach you about first aid is you have to survey the scene. Walk up and take a look at the whole scene where the person's injured. Like, for instance, I walk my dogs every night, and there's a spot where the telephone pole, just last week, goes like this. And it's obvious that a car slammed into the telephone pole. And the telephone pole's leaning over. What could happen if a telephone pole leans over? The lines could come down, the wires, and then you could have a sparking wire. And if there's a sparking wire, you don't go walking in there where there's a sparking wire, you could get electrocuted and die. So, you survey the scene, and that's what we do first when we read the problem. If 3 is subtracted from the quotient of a certain number and 7, the result is 15. Write an equation, find the number. So I just surveyed it, and I looked around to see if there was anything particularly dangerous going on now. There's not. Then I start, just like an EMT is going to come up to you, and they're going to sit there and they're going to check your pulse, they're going to check your breathing, they're going to see if you're okay that way, and then they'll investigate, and eventually they'll get to the injury. Well, that's kind of what we're going to do here. We surveyed the scene, everything is safe. Now, if 3 is subtracted from the quotient of a number and 7, and from is a very important word. We talked about from yesterday. If you drive to Las Vegas from Phoenix, where did you leave? Phoenix, that's where you were first. So from always goes first. So how do I write something for 3 is subtracted from the quotient of a number and 7? How do I write that? Go ahead.
I'm just gonna take a 7x minus 3.
Well, I like the minus 3, and I like the
That's
x,
x.
but it says quotient. Quotient means
Oh,
divide.
okay.
So it's x over 7 minus 3. Remember, quotient means divide. So I can cross all of this stuff out. Then it says the result is 15. So what do I write next? Everybody, come on, the next part's easy. Equals 15. Now, the only thing left is the directions. What does it tell you to do? Write an equation and find the number. So, what do you think my first step is here? In fact, you know what? I'm going to pause now and give you guys 30 seconds to do it, and then I'll do it for you. Go ahead. Or with you, I should say. No, let's get through this, and then we'll worry about you going through that. Remember, we do have lunch for that. Okay. So, what's my first step, everybody? Carmen, what do I do first here? Add 3, very good. So I do plus 3, die, x over 7 equals 18. Very good. Now, at this point, we haven't done too many like this, but we should know that we're always looking for inverses and opposites. So when it says x over 7, what operation is that?
Division.
Division. So what's the opposite of divide? Multiply. So I'm actually going to multiply by 7. Die. And 18 times 7 is 126. And that's my answer. Okay? Any questions?
I didn't get any of that.
Well, I have to multiply both sides by 7 because it said to divide, and I need to do opposites. Usually we put multiply, so we do the opposite and divide. Now we did divide, so we got to do the opposite and multiply. Do it to both sides. 18 times 7 is 126.
Well, I did something different.
Then you done did it wrong. Does this make sense?
Yeah.
Okay.
It's just because when I was with Mr. Beebe, I don't know if you know him. Is that Bay?
I heard of them, yeah.
He did something different because we had one of these equations once.
Yeah, I don't know that he
Like this,
did
and then-
like x over 7. That's not typically 5th grade work.
I had Mr. Alonso, so I was like in an advanced math class.
Yeah, maybe a little bit of it, but this is not typically elementary stuff. Okay, number 2, give it a shot. While you do that, I will sing for a couple of minutes while you're giving it a try. I can't, the word Camaro helps me out here. It just brings back such fond memories. So you do that, don't laugh at my singing as you do this, and I'll start singing. I got a 69 Chevy with a 396, Julie heads and a hearse on the floor. Keep going. She's waiting tonight down in the parking lot outside the 7-Eleven store. Me and my partner, Sonny, built her straight out of scratch, and he rides with me from town to town. We only run for the money, got no strings attached. We shut 'em up and then we shut 'em down. Tonight, the highway's bright. Oh, that's the end of the song. Hold it. Tonight, the strip's just right. We're gonna blow 'em off in my first heat. 'Cause summer's here and the time is right for racing in the street. Yes? No. But the end of that song goes, I met her on a strip 3 years ago in a Camaro with this dude from L.A. I blew that Camaro off my back and drove that little girl away.
So you
Now my baby sits on the porch. Yeah. All right. So anyway, that's a classic song called "Racing in the Street" by Bruce Springsteen. Truly one of the. I love the song. I think it's just a fantastic song. At one point, I let Angie listen to the song because she likes to race and go fast, and it's song about racing and go fast and how real men, real people. There's a line in there that says, some guys come home from work and wash it. Wait, no. Some guys, they just sit around thinking about living, doing nothing. And then some guys come home from work and wash up and go racing in the streets. And that's it. It's two kind of people. Kind of people who sit at home and think about stuff, watch TV. And got people who go home, wash their hands, get to business. All right, Billy measures a toy Camaro in centimeters on a ruler. If he triples the length and adds 9. Well, first off, do I care about the fact that it's a toy Camaro? No, the only thing I care about that is it makes me sing Bruce. All right.
Belly.
If he triples the length and adds 9, so let's use L for length. I hesitate with L because it kind of looks like a 1 sometimes, but I'm going to use a script L.
All right.
All right. So how do I write triple the length adds 9? How would I write that? Spencer, what do we got? 3L plus 9. You see how I made that look like an L script so that I couldn't confuse it with a 1? Right? I don't want people to think that's 31. Question?
No, I just always put a capital L for length.
Capital L is a good one too. That's an excellent way around it. Okay. Now, I'm going to triples the length and adds 9. Beautiful. What's he get? So what do I write? Equals 42. Nicely done. Just use it up, cross it off. Use it up, cross it off. How long is Billy's toy Camaro? So, what is my first step here? Miss Bueno. What do I do first? Beauteous, my dad would say this. He'd say Beauteous Maximus.
Oh.
Now, do you get that? Do you know what your gluteus maximus is?
Yes.
It's your butt muscle. So my dad would always say, Beauteous Maximus, maximum beauty. Die. 42 minus 9 is 33. 3L is 33. That's equals, not divided. What do I do next? Jerry, talk to me. Divide. Nicely done. I divide by 3.
11.
L equals 11. Good. So the Camaro is 11 centimeters long. Sound good? Okay. You, who asked first for the potty? Gabby? You can go to the potty, and everybody else do number 3, and then when she comes back, who asked over here for the potty? You can go when she comes back. Be quick. Yes, number 3 it is. Okay, so I hope you're using it and you're using things, crossing them off, using things, crossing them off. Jenny multiplies the number by 4. Johnny multiplies the same number by 2, adds 7. The sum of Johnny's and Jenny's is 37. Find the number. How would I say Jenny multiplies a number by 4?
4 times
4n, very good. It's very important when you do this, guys, do not put an X there, just 4n. Okay?
Why?
Because then what's the letter? Is it the X? Is the number the X or is the number the N? I don't know. So we never use an X for times anymore. We just use a dot or nothing at all.
No, but like, why do you use an N instead of an X? 'Cause
You could.
usually-
If you use an X, that's fine. I don't want X and N. That's what I don't want. Okay. Johnny multiplies the same number by 2 and then adds 7. How do I write that? Okay, Chris, what do we got?
Multiply 2.
Okay, so N times 2 and then what?
Equals 37.
Not quite yet. There's something you're forgetting. Johnny multiplies the number by 2. That's 2n. But then what else does it say? Oh, this was done. I crossed that off. Johnny multiplies the same number by 2. I did that. And then it says what? And then add 7. Okay, so that's what Johnny does. Now, here's the new curve in this situation. Rachel, you with me here? Right, Rachel? Whatever we're doing there, it's not learning how to do this. Okay? Check it out. It says the what? The sum. What does sum mean? What is sum operation? What operation? Add. The sum of Jenny and Johnny. In other words, if I add these two, the result is 37. Okay? And then is this a same side situation or an opposite side situation? Same side. So you would subtract 7 and get it all together, get 6 and so on. That's good enough for now. I want to get to the next problem and set that one up. Okay?
Wait,
Mm-hmm.
you subtract what?
You would add the ends together, get 6n, and then you would minus 7 from both sides. So it works out to, I believe, 5.
Yeah.
All right, this one is a little bit of a trickier question, and I want to make sure we get to it before we leave. 7 times the difference of twice a number and 3 is 49. Find the number. Now, somebody find something really easy in this to start with. I think there's something super easy to start with.
X times 2.
That's not super easy. Give me the super easy thing.
7x.
No, super easy. Way easier than those things.
Equals 40.
Yes, equals 49.
I know that.
So I can cross that off. Now, 7 times what?
The difference.
The difference. What does difference mean? No, subtract. 7 times the difference of what? 7 times the difference of
Twice the number.
twice a number and 3. How do I write the difference of twice a number and 3?
Times 2 plus 3.
Now plus, what's difference mean again? Subtract. So it's 2n minus 3. That's the difference of twice the number and 3. And then what did I didn't do yet? Look at there. It tells me what didn't I include yet?
7 times.
7 times. Now you've got, this is the danger moment. You have to put the parentheses around it. Okay. What would your first step be, everybody? Distribute. Very good. Okay, we'll keep working these word problems every day. Hasta la vista, vaya con Dios, toodaloo, ta-ta, arrivederci, smile a lot. Ciao, arrivederci, adios amigos y amigas. Cheerio.
Guidance office, please.
Carushurus, good office.